Hi viewers, welcome to this channel. This is Anthony Vijay, Assistant Professor, Department of Computer Science, Karpagam College of Engineering. Today's my topic is Introduction to Unsupervised Machine Learning. So first of all, we are going to see about the need of unsupervised learning. In order to learn the unlabeled data and hidden patterns from the dataset, we need unsupervised learning. And this type of technique does not require any supervision. Next, we are going to see about what is unsupervised learning. This is the type of machine learning in which models are trained using unlabeled data and it is allowed to act without any supervision. Next, we are going to see about why we need to use unsupervised learning. Unsupervised learning is much similar to human decision making, which is very closer to artificial intelligence, and it is taking care of unlabeled data and uncategorized data. This particular technique is mostly used for real-time scenarios. Next, we are going to see about the working of unsupervised learning. First of all, I am going to explain the diagram. Here we have taken unlabeled input. This particular data is applied to machine learning model to train itself. This model identify the hidden patterns from the input image with the help of k-means clustering algorithm. Next, we are going to see about what is k-means algorithm. It is an iterative algorithm. It means it divides the unlabeled data into k different clusters. It will create a group based on their similar properties. Here k means number of clusters. If the value of k is 2, there are 2 clusters. If it is 3, it means 3 clusters with 3 different properties. Next, we are going to see about steps in k-means algorithm. The first step, we need to find the Euclidean distance between each data, and next step is assign the centroids for each data points, and the third point is calculate the new centroid values based on the mean value. For example, here I have taken 10 data points which is denoted by D. The data points are 5, 3, 10, 15, 15, 12, 24, 10, 30, 45, 85, 70, 71, 80, 60, 78, 55, 52, and 80, 91. In this example, I have taken the value for k is 2. It means 2 clusters. It is denoted by C1 and C2. First of all, we randomly fix the value for C1 and C2 is 5, 3 and 10, 15. In iteration 1, 5, 3 is compared with the C1, it is 0. And again 5, 3 is compared with C2, it is 13. So here 0 is the minimum value. So 5, 3 is belongs to cluster 1. Next, we are moving to the second data point, that is 10, 15. While comparing with C1, it is 13, and for C2, it is 0. So second data point is belongs to C2. Let's see the third data point. It is 15, 12 is compared with the C1. It is 13.45, and for C2 it is 5.83. So 5.83 is minimum. So it is belongs to C2. So steps are repeated till 80, 91. So in this iteration 1, there are only one value for C1 and 9 other values for C2. So we have to find the average. For cluster 1, there is no need of average because it is only 1 point, so there is no updation in C1. But for C2 there are 9 data points, so we have to calculate the x coordinate separately and y coordinate separately. Likewise, see here, these all 9 elements are C2. So we have to take the x coordinate separately, that is 10 plus 15 plus 24 plus 30 plus till 80. This is what mentioned here, divided by 9 elements. So I am taking average, it is 47.77. Likewise, I am taking y coordinate. So for y coordinate, it is 15 plus 12 plus 10 plus till 91. Till 91. Divided by 9, it is 50.33. So the new updated value for C2 is 47.77, 50.33. Okay, let's see the second iteration. So in the second iteration, see the header, the C1 is same but C2 is updated here. The same process is repeated. Here the C1 is now 4 datas and for C2 is 6 datas. So x coordinates are added separately and y coordinates are added separately and taking average, getting 13.5 comma 10. This is for C1 right now. Now the C1 is updated. Likewise for C2, same x coordinates 30 plus 85 plus 71 till 80 divided by 6 elements. And for y coordinate, same 6 elements divided by 6, getting 69.33. So this is the updated one. See the next iteration. Now the header has changed for C1 as well as C2. Same process repeated. This particular iteration is stopped when the next iteration have the same value. Okay, so the iteration 3 is repeated and again they are checking. Now the value for C1 is 5 elements and for C2 is again 5 elements. So adding x coordinates separately and y coordinates separately, the value is 16.8 comma 17, and for C2 is same process 70.2 comma 74.2. Now we go for iteration 4. We are updating the header for C1 and C2. The same process is repeated. Again there is 5 C1 values and 5 C2 values. See here, the values are same, 16.8 comma 17 for iteration 4. For iteration 3 also 16.8 comma 17, and for C2 70.2 comma 74.2, here also 70.2 comma 74.2. So for iteration 3 and iteration 4, the values are same, so we are stopping the iteration. So this is the centroid position. So in this example, we have discussed the value for k is only 2. If you want to increase the value for k equal to 3, we will be getting 3 clusters. This is the example for k means clustering. Thank you very much.